In this video we will be using this little guy, which is a NOR flash memory which communicates with the SPI, and we will use it as a USB disk and also as a disk for the microcontroller. So we will use the FatFs together with it to write something to it. And this example writes a test string to the memory on startup. So we got our little disk right here, so nothing in it. Okay, so now I'm resetting the microcontroller, waiting 3 seconds, and I got a test string. Okay, so let's start with the project. Okay, so let's say this is our basic project. We got some clock initialization right here. Okay, and we would like to, with the use of ASF, add virtual memory in RAM, delay routines, of course the GPIO, the SPI, as a standard SPI, also with the driver, the file system FatFs, and the USB device as a mass storage option. Okay, so we got some files generated when doing so, and into the main I added function to initialize the minimal of the interrupts, something like hard fault and so on. Then delay, I make an init to the SPI, and this is a function located right here. Okay, right here I use the definitions right here to make the SPI work at 1 MHz, and it uses the SPI 0 and chip select also 0, so it's the pin D10 on the Arduino. And also make sure when doing the SPI initialization to add the definition for the board to make the pins work as a SPI. So SPI 0, chip select 0. Okay. Now on, we got the functions to handle the communication with the memory, the NOR flash. So right here the function to check upon the state of the device, if it's still busy or not. We can write something to it, or we have to wait. Next, on the write function for the whole sector, the erase whole sector function, which writes actually the 255 value to a 8-bit cell, the read whole sector function, and erase the whole memory. Just like in the SAM4S example, I use a delay which does USB transmission for the mass storage, and also delay 1 millisecond. And next on, I got a FatFs write test function, in which I write a test string to this file. Keep in mind to put in the drive location to the name of the file. So in this case 0. If you have multiple partitions, then it's for 2 partitions 0, 1, and for 1 partition it's just 0. Okay, going back to the main, after making the SPI work, I enable the SPIO-A peripheral for the pins of the SPI 0. It will be enabled in the SPI init function, but I'll just make sure to put it in. Also the clock for the LED pin, and I wait 3 seconds to make sure I don't get any resets right after the power up. After that, I make a write to the memory with FatFs, and then on I start the USB. You can start the USB earlier, it doesn't really do much. So you can, while having the USB started, you can make the FatFs write function. It's all okay. It's just when you make a write to the memory, make sure not to power down the board, because it can corrupt the FatFs descriptor. Okay, next on in the main loop, I just make the LED blink and handle the USB transmission. Okay, so now the thing with adding something to the project which is missing, and this is the definition of the memory to RAM access. So the FatFs write and read functions to the virtual memory. So in this case, not the virtual memory, but NOR flash. And that's because in the virtual memory functions, I changed the from the access to the RAM in the microcontroller to the writing and reading from the NOR flash memory. So this functions, this whole file is pretty much similar to the one in the SAM4S example, with a slight change, which is declaring this buffer not in the C file of the virtual memory, but instead, always when this variable occurs, it's an extern. So in the USB, it's an extern, and also in the functions of the FatFs, it's also an extern, right here and right here. And this variable is declared at the top of the main to make sure we have space for it, because in the SAM3X we got some more limited resources of memory than in the SAM4S. So if you don't do this, you might get a hard fault. So keep in mind to use it like so. Okay, so what's to do right here? The first thing is to go to the conf virtual memo and declare the number of sectors you have. So for the 16 megabyte, you can calculate it just like 16 megabyte divided by 512 bytes. It will make this value. You can also declare less than this, so we will use less disk memory, and the rest of it will be left unused, or you can just use it as a raw access. Okay, and as usual, you will have to make a configuration of the FatFs. So in this case, make sure to have it like so. So the sector size is the 512, and the functions str func is 1 or maybe even 2. In this case 2. So you can access the files there, write and read from it in the FatFs. Okay, so that's pretty much it. You will have to change those files only, and in the main add those functions which I added. So let's change it up a little bit, and instead of the test we will write something like sem3x string to it. Let's compile it. Okay, now let's make erase on the board. Select the port. I already got the binary file selected. Make sure to check the erase all option and the boot to flash option. If you don't do this, it will get stuck in the bootloader state, like forever. So keep in mind to check it. There's no flash offset, so that's okay. So now we can just write it. Okay, so now I'm clicking reset on the board. And after 3 seconds I got the disconnected, and I got our changed up string right here. So thanks for watching, hope you find it useful in your project, and see you in the next one.